Okay, so you've already calculated and hopefully understand where they got this 6,108. So they took 1.8%, they changed that to a decimal, multiplied it by the 6,000, and added it to the original 6,000. So if they want to know what the population will be in 2 years, you'll take the population currently in year 1, multiply that by the rate again, rate of growth. And if you add that to the population after 1 year, you should get 6,217.944. The 944 isn't very meaningful, so let's just round it off to that. There we go. And then in 3 years, you'd repeat the process and hopefully get, oh my goodness, that was interesting. Sorry about that big line. And I rounded, so you might get a little different answer if you don't round, which would be a little more exact. But I think it makes sense to round because we don't have parts of people. Okay, and we can tell this is exponential because if we graphed it, we'd see it's going up really fast. Okay, take a look at this next question, and I'll let you read it, and will you pause the video, and then I'll work it out with you. Ah, computer froze. There we go. Okay, so this equation is a little tricky. What this means is you take the population that you want to find out. That'll be your equals. It'll be equal to that. You do that by taking the initial population and multiplying it times 1 plus the rate of growth. And if you notice in the previous example, that's what we were doing. So we were taking this original thing, this is 1 times this, adding it to the rate, and then getting the new answer. So the shortcut is to write it in that notation. The shortcut is to use this notation, where it's 1 plus the rate times how many years or months you're interested in. So given this, let's write the equation for uptown. Uptown is the 1.8, I believe. So we want to put that in as U of T. The initial is 6,000. Doing it. And that's a little exponent, a little t. So that's also how you can know it's an exponential equation. Okay, now you can pause it and look at the next question. Okay, in this one we will do this kind of slow way first. So we'll say the population after 1 year, and then we'll multiply it times that, times the rate, it's declining. Oh, excuse me, we want to subtract here. Because it's declining. Work that out. I'm looking. Your answer book says you should have a 5 there. Half a person, I guess. Okay, so once you work out the pause it and work out the 3-year one. Okay, oh, and they said just to write the expression. So it'll either be that's one way to write the expression with a 1 minus, but you could also write it like this. So it ends up being the same answer, but this way shorter. So I'd recommend writing it that way. And then the general equation for that is the downtown equation, is the initial, which was 20,000. The R was 0.15 or 0.015 times the time. And so that will get us to any time you want to know about. If you can replace t with 5 years or 6 years, get you anything you need to know. Okay, now turn the page and we'll look on page 308 and we'll graph these equations. So you can either go to Desmos, or if you have a graphing calculator, you can use that. And we'll need to change them to say y equals. So y equals and then we'll need to change that to a little x. And you probably, on Desmos, you'd have to do a little caret to make an x, but on graphing calculator, you can find the exponent for x. Well, actually, maybe you have to use the caret there too. And then make sure you have that as a small x, an exponent x. Okay?